So this is lesson 2 of Unit 11. It's based on finding the standard deviation, z-scores, and labeling and using the normal curve to make sense of statistics. So the first thing you need to do is to warm up. So you're going to read the following and answer the questions below. And I will read through it for you if you need me to. And then at the bottom, you should be answering these questions. This is a test of your reading skills here, okay? So I'll read it to you. You should probably read along. All right? It says, first, the standard deviation is an important part of statistics. The symbol for standard deviation is sigma. You're going to need to use it in different ways for many different types of problems as you go forward. So it is important that you understand now. If you can manage, it will be helpful to you later on if you have these numbers memorized. The line down the middle is called the mean. It is represented by mu, or the symbol for mu. On either side of the mean are equally spaced deviations. Because the lines slope downwards on either side of the mean, the area inside of each deviation grows exponentially smaller the farther it is from the mean. The proportions of the normal curve will always be the same for normally distributed data sets, which means the percentage of data within each deviation is the same for every set. So, for your questions, first question, what is the symbol for the mean? Well, if you go back up and read, go back up and read. You start, the line down the middle is called the mean. So here's the mean. It is represented by the symbol mu. So here's the symbol for the mean. Second question, what is the symbol for the standard deviation? Standard deviation is an important part of statistics. The symbol for standard deviation is sigma. So you go down and you write it, sigma. So go ahead, use this graphic to help you answer the other questions. I'm not going to fill them out for you. I think you should find the answers on your own. Pause this video for about 2 minutes and answer those questions at the bottom. All right, so we're going to move on to the actual notes for this class. Okay, so for this unit, for this lesson actually, 2 big words here we're going to be using. So the z-score and the standard deviation. I'll write that a little bit neater. Standard deviation. Each of these measures of central tendency are used to measure how far a data point is from the mean set of data. So in a list, it helps us predict how far, how many people percentage-wise fall into a certain category or get a certain score. So today we're going to use this data here. 79, 81, 83, 85, 87, 89, 91. These are test scores. And the first thing I want you to do, pick up your graphing calculator. Get the practice to find the mean and the standard deviation in your calculator. So in your calculator, your mean, don't forget, it's not the mu, it's going to be x bar. Okay, standard deviation in your calculator is going to be sigma x. So go ahead, put those numbers in. I'll do it with you. So I have to stress that if you are at this time not taking full advantage of the video and being able to refer back to it, if you are not at this time turning on your calculator and putting this information in, you do yourself a disservice. And while it's a little bit off topic, I will tell you that I have been having conversations with students who are now out of high school, and they weren't all my students. A lot of them just aren't, but they're finding it very difficult to get by because they don't have the math background that they need. This is only Algebra 1. And if you are struggling to follow directions now because you choose not to, that's unfortunate, and it's not going to land you in the best place that you would like to be. You want to take this opportunity now, while you're in Algebra 1, to do the things that you know you need to be doing to prepare yourself to be the best you as you move forward. So if you're not following directions, that's a choice that you make. So I would hope that you would make the best choice for you, because your decisions aren't going to directly impact me. They might make me sad if you choose not to make the best of these opportunities, but they're not going to directly impact me. And I say this for your own benefit and in the hopes that you would make good choices. So we're going to go back to this part. So we're putting these numbers in. So the first thing you do is to press stat. Then you're going to press enter. And remember, I told you last week, I said if you want to clear out a list, you see I'm in list 1. I press up, I press clear, and enter. You should not be pressing delete. You press delete, you're going to make mistakes. So I refer back to my list of numbers on page 10, and I have 79, enter, 81, enter, 83, enter, 85, enter, 87, enter, 89, enter, 91, enter. Alright, so at the bottom it says 8 right there, okay? So we should see an 8 there, okay? For the number of spaces you have on that list. The next thing we want to go back to stats, right arrow over to calc, press enter on one variable. And then we go down, press enter, enter, enter. And we go back and we fill this information in. So my mean is 85, my standard deviation is 4. So my mean, a score of 85, my standard deviation is 4. So we're going to graph this normal curve. Things I know already, right here, my mean is at 85. And everything else falls to either side of that normal curve. One of the next things we're going to do is to identify the parts of the normal curve. And then we're going to go back for the second part, and we're going to pretty much graph the percentages, be able to look at the percentages of people that fall within a certain score range. So we use the normal curve. That's what it's called. It's just this bell-shaped curve to make predictions about the number of students who will make a certain grade. So we use it to make predictions about statistics in general. All right. So the next thing we're going to do is we're going to practice labeling this normal curve, like I said. So let's go ahead. So I'm not going to read through those directions. I just want to talk about what the normal curve looks like in general. So in general, your normal curve in the middle of that normal curve, we have mu, or the mean. And we usually write mu equals some number right there. Okay? If we move over, we're going to be writing a lot here, so make sure you use your best handwriting. If we move over here, if I move over one tick mark from the standard deviation, from the mean, sorry, in either direction, this is 1 and this is 1. I move by, I say minus 1 standard deviation for the left part, and then plus 1 standard deviation over here. So let's say that the mean is 100. And let's say my standard deviation is, I don't know, 10. So that means right here, my mean is 100. That means minus 10 is 90. So from within 1 standard deviation, I have 90 to the left, and I have 110 to the right. So standard deviation is 10. So if I go left, I'm going to subtract a standard deviation to get the next tick mark. If I go right, I'm going to add a standard deviation to get the next tick mark. So keeping that in mind, the next movement, I've moved 1, 2 standard deviations to the left. So that means I subtract another sigma. That's 2 sigmas in all. And I should have 80 as my second standard deviation to the left. But to the right, 1, 2. So I'm adding 2 standard deviations, or adding 20 to 100. I have 120. So you can imagine the next step, removing 3 standard deviations. So I'll move 1, 2, 3. And here I have 70. So, positive 70. And over here I have positive 130. So correct labeling would be to say, at this tick mark, if I want a formula, mu, the mean, minus 1 standard deviation. Here, the mean minus 2 standard deviations. Here, the mean minus 3 standard deviations. There's nothing complicated about that. Over here, on the right-hand side, the mean plus 1 standard deviation. The mean plus 2 standard deviations of this tick mark, and the mean plus 3 standard deviations. Okay? This is the correct labeling. Things I want you to outline here. I want you to create these little bars. Anything that falls within 1 standard deviation means that 68% of people made that score or did whatever. However, anything right here means that 13.5% of people did something on either side, okay? And right here, that means 2.35% of the population falls within 3 standard deviations of the mean, as well as over here. If I have a score way over here between 70 and 80, 2.35% of the population falls within that of that score range. That's how we read it. So we're going to use statistics. We're going to use the information that we had before from that list of numbers on page 9, and we're going to label this new curve. We're still going to use this information here. Okay? So we're going to label with all this information first, and then we're going to go back and put numbers in. So, first things first, my mean is 85 for this particular list of numbers. My standard deviation is 4. Okay? So the first formula is mu minus sigma. So what we're going to do is we're going to label. So here's my mean. And within one standard deviation, how do I know it's one standard deviation? Because we're going to write it. Mu minus sigma. Mu plus sigma. So here, I got it blocked off. 68% of a population has a score between these two tick marks, or within one standard deviation of the mean. So, what are the numbers for these? What's the lowest number, and what's the highest number? So between what two numbers? So 85, the mean is 85, minus the standard deviation, or minus 4 equals 81. So on the low end, anyone with a score between 81, and on the high end, let's see, this equals 85 plus 4, that's 89. Between 81 and 89, well, 68% of the population. So I'm going to write that 68% of people in this class have a score of between B/T 81 and 89. Okay? Now, here, this little bar here, 13.5%. So from here to here, 13.5% of people have a score between, what's 81 minus 4? 81 minus 4. Well, that's 77. So between 13.5% have a score between 77 and 81%. 81. Score between 77 and 81. Whereas on the other side, 13.5% of the population have a score between 89 and, well, 89 plus 4 equals 93. So 13.5% have a score between 77 and 81, as well as between 89 and 93. Okay? So the percentages keep getting smaller as we move and bigger as we move away from the mean. But the number of people, yeah, so that makes sense. But the number of people decrease as we move farther and farther away from the average, which makes sense. Most of the people have an 85, somewhere within a range of 81 or 89. For 3 standard deviations, we have our last number, 77 minus 4 equals 73 is my lowest grade we're looking at. Anything beyond that is an anomaly. 93 plus 4 is a 97. So here I have 97. Anything beyond that is an anomaly. So let's go ahead and answer these questions. It says, how many standard deviations from the mean is a score of 89? So I'm going to find 89. And if I look, it's 1 tick mark away. So it's 1 sigma, or 1 standard deviation. You could also write 1 S period D period. Number 2, how many standard deviations away from the mean is a score of 97? So if I count 1, 2, 3. 3 standard deviations, or 3 SD. What about 93? 2 standard deviations. Okay? And 77, I want to be specific, it's minus 2 standard deviations because it's This means it's lower than the mean. It's lower than the mean. Should we use the negative signs? Yes, we should use that negative sign because it means that it's lower than the mean. We want to be specific. Okay? What about scores like 87 and 89? So they're falling within one standard deviation. That's how we say it. So 87 is somewhere between 85 and 89. So it's within one standard deviation. Okay? How many standard deviations away from the mean is a score like 79? Well, it's within, let's see, 1, 2, within 2 standard deviations. Okay? And so what we're talking about right now is something called a z-score. It kind of tells us how many standard deviations away we are from the mean. Like, where about are we? Z-score should never really go past 3 and -3 because we only go to 3 and -3 standard deviations, okay? But we have a formula for the z-score, so we don't have to guesstimate. It's z equals x, or just one of the scores, one of the data points. And we're going to use that same list of numbers. Our mean here is 85. Our standard deviation is 4. So for the following problems, please use the mean and standard deviation from the test scores above. How many standard deviations away from the mean is a score of 81? So here, x is 81. Standard deviation is 4, mean is 85. So we're just going to put it in a formula. X minus mu divided by sigma equals, my x is 81 minus 85 divided by 4. So I'm going to go to my calculator, put this in. So alpha, second mode, alpha y equals, enter, 81 minus 85 over 4, enter. And my z-score is equal to -1. Now for 88.5, alpha y equals, enter, 88.5 minus 85 divided by 4. Z-score is 0.875. We want to keep it in fraction form. We don't want to do that. We want decimals for statistics. Okay? So writing it out, have 88.5 minus 85 divided by 4 equals 0.875. So down below, I'm going to do the left-hand side. You're going to do the right-hand side. All right, so Z equals my data points is in this column. For the second column, your data point is here. So it's asking you to find a z-score for each data point. So here I'm going to put 97 minus 85 divided by 4. And I get, let's see, 12 over 4, or a z-score of 3. Okay? Well, 90.5 minus 85 divided by 4. All I'm doing is using the formula z equals x minus 85 minus the mean divided by the standard deviation. So I go to alpha y equals 90.5 minus 85 divided by 4. You should do this on your own. And your z-score is 1.375. Let's do the next one. You should have 81 minus 85 divided by 4 equals -1. So here, all of these are classwork on this row, and you can do those on your own. So the last part I want to go over is using data points. So you're going to be using the same formula, z equals x minus mu divided by sigma. The only thing is you won't have x. Okay? We'll be solving for x. So, next thing, so we're going to be plugging these numbers in, and just to be sure we're on the same page here, you should be on page 14 because you're going to need this information in order to do your homework and classwork. So, here's my formula, z equals x minus mu divided by sigma. So I'm going to write this out. I'm going to show our work here in this column. And then we're going to write the answer versus data point x. So z equals x minus mu divided by sigma. So, okay, so we have 2 equals x minus 8 divided by 2. And so basically, we're dividing by a number, and we're solving for a variable this way. You're going to multiply 2 on both sides. You're going to see that we do the same thing each time. So 2 times 2 is 4 equals, these cancel, x minus 8. I add 8 to both sides, and you should get x equals 4 equals x minus 8. I add 8 to both sides. I just rewrote it up here. It's easier. And x equals, this cancels, 4 plus 8 is 12. So here, my data point is x equals 12. Okay? So we're going to do the same thing again. Using this formula, z is 2.82 equals x minus the mean, 5, divided by the standard deviation. So we're going to want to get x by itself, so we multiply 6.2 on both sides. Okay? So 6.2 times 2.82 equals 17.484. This equals x minus 5. 6.2's cancel on this side. So we add 5 to both sides. And then 17.484 plus 5 equals 22.484. So x equals 22.484. On the last one, z equals negative 1.27. This equals x minus the mean, which is negative 50, divided by, excuse me, not all the way across, guys, divided by the standard deviation, 5.5. Remember, we're always multiplying that standard deviation on both sides. So I want to use parentheses when there's a negative number. Now, 5.5 times negative 1.27, and I get negative 6.985 equals, these cancel, x plus 50. Alright, subtract 50 from both sides, and I get x equals negative 56.985. So I'm going to write that over here. X equals negative 56.985 as my data point. So, this is the end of this unit. It's a very short unit. We'll be referring to things more often. So, All you'll need to do after this is just do the classwork. It's on page 15 and 16. 17. It's 15, 16, 17. Do that. Turn it in. Next class. You should be doing your J-Labs every week. They are due. They are a grade. They are a quiz grade, so they're a major grade for this class. I cannot stress enough that you do the work that you need to do right now. Have a good day, guys.